Welcome to today's training. This video will cover shop safety, laying out a part, using a bandsaw, using a drop saw, using a drill press, and using a sander. If your project is going to be made out of wood, needs precision-made metal parts, or needs to be welded, you will need to get upgrades to your permit. Upgrades are listed on the Student Shop website, coestudentshop.engr.wisc.edu. Safety is extremely important, and safety rules apply whether you are working in the shop, the Discovery Center, or your own workspace. All jewelry, including rings, watches, dangling earrings, bracelets, necklaces, or neckerchiefs, cannot be worn. Earphone cords, like those for your iPod or phone, strings from a hoodie, or other items that could become entangled in moving machinery are also prohibited. Long pants, shirts, and fully enclosed shoes are required. Long sleeves must be rolled up above the elbow. Tank tops, muscle shirts, low-cut shirts, sweatshirts, shorts, skirts, sandals, and flats are not allowed. Long hair must be tied back or otherwise adequately restrained. You may use a suitable hat, welding cap, or hairnet. Veils or hijabs must be approved by student shop staff. Loose-fitting veils or hijabs are not allowed. Gloves should always be removed before operating a machine. If your material is rough or sharp and gloves must be worn, handle the material with the machine turned off. Eye protection must be properly worn at all times, even when wearing a face shield or welding helmet. Sunglasses and prescription glasses are not safety glasses. Face shields with hearing protection are required when using hand grinders. Cell phones and other electronic devices should not be used in the shop. Always follow instructions given by student shop staff. To lay out the red part, you will need the following: the print, a piece of plastic coated with red layout dye, combination square, scribe, punch, ball peen hammer, dividers. Layout die allows you to mark your material and leave a highly visible line by which you can machine. The combination square is used for measuring and as a straight edge for scribing lines. The head is adjusted by loosening the thumb screw, allowing it to slide along the blade. The head has a surface set at 90 degrees and another at 45 degrees. Set the blade so an inch mark is lined up with a 90-degree beam. This will make measuring much easier. A protractor head and center head are also available. The scribe is used to mark your part. It can score most common materials, including steel. The punch is used to create a small indentation in your material. This is useful when you need to drill a hole. Your center drill will drop into the small indentation the punch creates. Next is the ball peen hammer. Use the flat side. The round side is for peening, an operation we won't cover today. Dividers are used to create arcs and circles precisely. They are adjusted using the thumb screw. To set the divider, place one end of it in a 1-inch mark on the blade. The blade is stamped so you can feel the point fall into the mark as you line the divider up. Don't use the end of the blade. It makes it difficult to hold the point of the divider at the exact location. Adjust the thumb screw until spacing of the legs is 1 inch. The print shows a rectangular part. On the right side, 1 inch from the end is a line. There is a line at 1 inch and 2 inches from the left side of the part. They are intersected by a line 1 inch from the top side. Each of these points will be center punched. The point at 2 inches will be drilled and tapped on a drill press. After punching the point 1 inch from the end, you can use the dividers to scribe the arc. The print also contains information in the title block that you need to know. This includes the type of material, tolerances, and finish requirements. First, lay the combination square on the part with the beam against the end and the blade alongside the length of the part. Make a mark 1 inch from the end. Now repeat the process to make marks at 1 inch and 2 inches from the opposite end. Turn the square 90 degrees. Holding the beam against the side of the part, line the blade up with each mark. Scribe a line across the part at each mark, leaving 3 lines like this. You now need to mark the middle of these last 2 lines. Hold the beam of the square against the long side with the blade along the short side and make a mark 1 inch in. Rotate the part 90 degrees, hold the beam against the short side of the part, and scribe a line intersecting the previous 2 lines. Holding the punch at 45 degrees, line the point up with an intersection and stand it up. Using the hammer, strike the punch firmly. Repeat this process for the other intersection. Place one leg of the divider into the indentation created by the punch 1 inch from the end of the part and scribe a radius. The parts are not square, so your lines won't be perfect. That's okay. This is an exercise to provide you with practice, not to make a perfect part. You are now ready to put on safety glasses and lay out your part. We have 2 types of vertical bandsaws in the shop. Woodworking bandsaws have a tension arm that must be set before turning the machine on. Raise the arm until it aligns with the red triangle. Turn it on or off using the green and red buttons. These saws can cut wood or plastic. Remove the tension from the blade after use by lowering the arm to the tabletop. The bandsaws in the Discovery Center and shop can cut plastic, aluminum, brass, copper, steel, and stainless steel unless otherwise marked. The on-off switches are located here. The blue hose provides air to move chips off your line. The blade guide is here. It can be unlocked with the bottom handle and then adjusted using the top handle. The blade guard should be about 1/4 inch above your material. This will keep the blade rigid, giving a straighter cut. It also protects your fingers. Tighten the lower handle to keep the blade guard from moving. When using a saw blade, remember the 3-tooth rule. The 3-tooth rule states the blade must always have at least 3 teeth engaged in the material. Anything less can damage the saw blade. To prevent round stock from rotating when cut, use a vise. Flip it upside down and hold it on the tabletop while tightening on your stock. Raise the blade guard to clear the vise if necessary. Before attempting a curved cut, contact a staff member as it requires a special technique. Keep hands at least 2 inches away from a moving blade. A push stick, wood block, universal work holding jaw, or vise can help. It is okay to cut into push sticks and wood blocks. Use wax lubrication on each side of the blade before a heavy cut. Raise your blade guard 1/4 inch above your part. Using a push stick, cut the corners off in a straight line. Apply constant pressure until the cut is completed. The radius will be created with the sander. Once complete, wait until the blade has stopped moving and use a chip brush to clean up. After you clean up, lower the blade guard. All drop saws are for metals or plastics only, no wood. All of the drop saws in the student shop work in similar ways. The saw arm has a single pivot point, allowing the blade to cut in an arc. Due to that arc, the blade will initially come into contact with only a small area of the material. Remember the three-tooth rule. Square stock will cause the blade to come into contact with a sharp corner. To protect the blade, reduce the feed rate. The saws have hydraulic controls, allowing you to raise the arm and lock it in position by tightening this knob or flipping this lever. Set the feed rate of the saw by opening the valve. As the cut starts, feed the blade slowly. After the blade is in the material, you can slightly increase the feed. Feeding the blade too fast can lead to tapered cuts. The vise jaws, here, can be adjusted by turning this handle. When cutting a short piece, equalize the clamping pressure by adding an equal width piece to the other side. Angle iron needs to be clamped with the point up. Coolant is needed when cutting metal or large pieces of plastic. For this piece, you do not need coolant. The blade guide is here. You need to adjust it so the blade is supported as close to the workpiece as possible without the guide hitting the table or vise jaw. Some of our machines can cut angles. Watch our videos online to see how they operate. Lift and lock the saw blade in the up position with the feed control knob. Ensure the vise area is free of chips and insert your material. Lower the blade slowly over the piece and stop the blade just above the part to check and adjust the cut location. Tighten the vise, ensure your piece is securely clamped and the blade guard is adjusted. Turn on the saw, adjust the cutting fluid and feed rate. When finished, lift the blade, shut off the feed, and remove your piece. Make sure to clean the saw after use and return the blade to the down position. Use a chip brush and scoop to clean up your chips. Try to leave as much of the coolant in the saw as possible. Locate the on-off switches. Now determine the direction the sandpaper is moving. On a round disc, you want to use the side where the sandpaper is moving down towards the table. If you use the opposite side, your part could get ripped out of your hands and go flying. On both the disc and belt style, your part needs to be in contact with the table at all times. If you hold your part in the air, it could pull your part downward and your hand into the sander. Smaller parts may need to be held with vise grips to keep your hands clear of the sandpaper. To sand the radius on the end of your part, place the part on the table. Start near one side and rotate the part. Take light passes. You do not want to melt the plastic. Try to use the entire belt or about half the disc when sanding. This spreads out the use of the sandpaper, allowing it to last longer. You will notice a burr on the radius after sanding. To remove it, use a swivel deburr tool. Hold the part with the burr side up, place the blade on the part, and pull towards you. You can also use a file. Remember to push the file away from you. Files only cut on a push stroke. The closing drill press must be turned on before changing speed. With the machine running, adjust the speed with the spindle speed handle. The lowest listed number is the operating speed. The head of the drill press contains the motor and gearbox, which is used to change the spindle speed. While the machine is off, consult a speed chart and set the levers to the proper position. You need to hear the click to make sure the gear is in place, otherwise you will grind the gears. The on-off switch has a high and low range. Some machines also have a reverse. Always run the machine in forward. The quill handle will move the quill and spindle. The table can be moved. First, release the lock on the left side of the column. Then use the crank to move the table to the desired height. You can also move the table left or right. Lock the table after adjusting it. To operate the vise, place the part onto the parallels. Use the long handle to close the jaws and toggle the short handle to tighten the jaws. You should not be able to remove the part from the vise if done properly. Your part can be secured to the table in various ways. Vise grips, clamps, toe clamps, and vices are the most common. It can be useful to set up a catch bar to prevent your piece from spinning. When using a vise, make sure the handle is to the left. The spindle spins clockwise and is powerful enough to spin your part, the vise, and clamps if not secured properly. The handle sticks out past the edge of the table and can strike you if the handle is set up to the right. If you have material too big for the vise, place a piece of wood underneath the part and clamp both the wood and the part to the table. You can drill into the wood, but please do not drill into the table. It is very expensive to replace. Have shop staff check your setup before drilling. There are two types of drill chucks, keyed and keyless. When using a keyed drill chuck, tighten it with its key at all three locations. Remove the chuck key before you start the machine. A keyless chuck tightens by firmly grasping the chuck here and twisting your lower hand to the right to tighten or to the left to loosen. You will need the following to drill and tap your part: a number 3 center drill, a number 7 drill, a countersink, a 1/4-20 tap with tap handle, and a tap block. A center drill is used first to help the drill pick up the location you wish to drill. The web of the drill does not cut, but rather displaces material. The center drill removes the material the drill has a difficult time cutting. The center drill also has a 60-degree countersink included. The drill only cuts on the angled edges. The edges going up the sides are sharp but do not cut the material. Chips are removed through the flutes, these channels here. The countersink needs to be run very slow, around 150 to 250 RPM. The tap has a tapered point. This first section creates only a portion of the threads. A bolt will not be able to engage in these threads, so if your hole does not go all the way through, make sure you drill your hole deep enough to account for this. Before machining, identify the type of material, then consult a speed chart to determine what speed the spindle needs to be set to. This is a good starting point. If the drill starts squeaking loudly, or with metals you see blue or black chips, or with plastic the material starts to melt, you may need to slow the speed down. Always use lubrication, except with thin plastic parts like the one you will be machining today. Drill with a pecking motion. Peck drilling is when you use small steps to limit the size of the chips being made. Peck drilling breaks the chips, preventing long chips from forming. It also removes the chips from the hole, clearing the way for more chips. This will help prevent the drill from breaking. Install the center drill into the drill chuck. Using the quill handle, lower the center drill into the indentation at the 2-inch mark. Once you have found the center, raise the quill and turn the spindle on. Drill until the angled portion is slightly larger than the diameter of the drill you wish to use. Remember to peck drill. Remove the center drill and install a number 7 drill. Find the center again the same way you found it with the center drill. Once again, peck drill, this time drilling all the way through. Replace the drill with a countersink and reduce the speed of the machine. Take your piece out of the vise and with both hands raise it up until you cut a nice chamfer on the hole. Flip the part over and do the same thing. Locate the V-notches inside the tap handle. Align the corners of the end of the tap with them, Then insert the tap and tighten the tap handle. To use the tap block, insert the tap into the smallest hole it will slide through. Hold the block against the handle and place the point of the tap into the hole. Allow the block to slide down to the top of your material and press the block down onto the material surface. This will hold the tap perpendicular to the surface of the part. This will ensure the bolt will go into the part straight. Turn the tap handle 3 half turns in a clockwise motion. Now back up 1 half turn. By turning back 1 half turn, you are breaking the chips in the hole and making room for more chips to be made. If you fail to do this, you could break the tap. Continue the 3 forward, 1 back process until the tapered section of the tap is completely through the part. Once it is all the way through, you can back the tap all the way out of the material. Here are some important things to remember. Always wear your safety glasses. Never walk away from a machine while it is running. Always clean up after yourself. Wear appropriate clothing and shoes. No jewelry. Keep your hair up above your shoulders. Follow all staff instructions.